So today is week 5, and today we will study what is sampling and what is mean by sampling distribution and why it is important in our statistical analysis and any other field. So from the word sample, sample means a small portion of a big population. For example, I define these definitions briefly. Number one thing is, what is a population? So population is a collection of all elements of interest. For example, in Karachi, you want to see how many people own their own house and how many people are living as tenants with tenancy agreements. So that means your population of interest is defined with how many owns and how many tenants. So that's a population. For example, patients who have heart diseases like MI or CVD. So they are two main causes of heart problems. So MI or CVD, how many patients have heart diseases? So this is a target population where you will be working to find some further details. So, for example, how many people living below the poverty line? So, poverty line defined by the government is that any person having salary of 18,000 or below is called a person who is living below poverty line. So, these are all different types of populations that we can define. For example, population of a particular animal in a particular village or particular forest. So this is also example of a population. So what is a sample? Sample is basically a small portion or a small part of the population. Normally, we try to estimate the sample we try to get a sample from the population in such a way that the population can be represented by that small sample. Usually, theoretically, if we talk about sample size, the sample size should be 15% to 20% of the population. So, for example, if you have a population of 1,000 people or 1,000 individuals, they can be product, they can be animals, they can be human or whatever. So, if a population size is 1,000, that means there should be from 150 to 200 sample observations that should be sampled from the population. But that sample means you have to invest human resources, you have to invest paperwork, you have to do some computer work. Then in other words, we say there are different types of costs that are involved that when we do sampling. In you have that's the census stands for you completely enumerate every individual in the whole country or whole province. So for example, if there are 50 million people in a population, that means you have to collect data about each of the 50 million people. And it will take, it will take at least 3 months to 6 months or maybe 1 year to do this heavy job. And it will cost a lot of money that need to be invested. But there could be another alternative way, which is called sampling. Sampling means we collect a representative sample from the population. Representative means the sample nearly represent the same characteristics as the population have. And non-representative means you collect a sample. For example, you are talking about poverty people who are living below poverty line, and you are collecting data from a very posh area, just like, for example, Defense or Clifton. So maybe by definition in the defense, they will say a person who don't have a four-wheel is a poor person or a person living below poverty line. So you have to see where from you are collecting data, and is the sample will work as a representative of the population, or it will not useful. So this is also another thing of interest, that we have to decide where from we collect the data, and it will be representative or it will not be a representative of the population. Second thing is called probabilistic sample, because for example, I showed this diagram. So for example, you have hundreds and thousands of people in a population, and you just sample 5% of them. Suppose you have 100,000 people and you sampled 5%, means 5,000 people out of it. So, but if you select 5,000 people, then again you sample 5,000 people, then again you sample 5,000 people. So maybe a person who is selected in one, maybe this sample have this person, Maybe the other sample have some other people, and other sample will have some other people. What I want to say that when we do sample or sample collection from a population, there could be many different samples. Just for example, if I say 100,000 people and 5,000 is the sample size, that means I can have 20 different samples of size 5,000 where there is no person repeated in any sample. So that means samples are themselves becomes a random variable, random quantity, probabilistic. So that's why we say that we have to collect a sample which is true representative of the population. And if it is not a true representative, yes.
सर ये रिप्रेजेंटेटिव और नॉन रिप्रेजेंटेटिव एक दफा फिर बताइए प्लीज.
Representative means the sample is capable to represent the whole population. For example, in Pakistan, they do approximately 40,000 to 50,000 COVID patient tests. Based on this, if they get a proportion, suppose the proportion of the positive cases is 5%, they say based on the sample information of only 40,000, they say the whole Pakistan have a percentage of positive cases equal to 5%. So that means they assume that the sample data they have collected is representing the whole country. Because Pakistan की population जो है वो तो 220 million या उससे ज़्यादा ही है. 1 million 10 नहीं, ये तो 10 million is equal to 1 crore. So 20 crore 10 crore के लिए 100 million
220 million sir.
220 million approximately. So if you want to do the data collection for 220 million population, it will take 2 to 3 years. But if you just represent that we have collected data from 40,000 random samples, and from 40,000 the proportion of positive cases is 5%, and then you say based on the 40,000 people we can say the whole country have a percentage of 5%. So this is representation of the whole population proportion of positive cases based on only sample information. लेकिन ऐसा हो कि आप किसी ऐसी एरिया में चले जाएं जहाँ पे बहुत ज़्यादा कोविड है, and then you collect sample from them, that means maybe the COVID cases will be more than 10%. If you say then that the whole Pakistan have more than 10% positive cases, this is not representative, because you are collecting data from very biased area. Bias means a specific area. So when we do sampling, there are a lot of many different techniques that we have to follow. But at the moment, we have only
Thank you. सर एक सवाल है सर, फिर सैंपल में जो डेटा हमारे पास आएगा तो
put it on mute. Okay, so now there are some basic definition in 2-3 slides. Their concepts. Parameter are characteristic of a population. For example, the target population. For example, if you are focused about COVID cases, then population of target population will be COVID or non-COVID patients. So if you are talking about poor and rich people, so your target will be some specific population. You will not include children below 18 years old. So that means you have to define the target population. And the population parameter means like population mean, population variance, population proportion, population ratio, population correlation, and so on. So these are all called the parameters or population characteristics. But if we go for the sample characteristics such as, for example, sample mean, X bar, sample variance S square, and sample proportion small p, sample ratio small q. So these are all called the sample statistics. So we have parameter defining the population characteristic, and statistic not without s, statistic not s, without s, that is called the sample quality or sample property. So for example, yeah, sampling error is the difference between so basically, so sample statistic or statistic is called the estimator or a single point estimator. For example, we say sample mean X bar is used to represent the population mean mu. That is called a point estimator. That we are just using one point to say, for example, yeah, the COVID example is better. Based on the sample proportion of 5% from 40,000 people, we estimate the proportion of positive cases in the whole population of 220 million. So this is called a estimation process. Estimate means to approximate or to understand, And sample characteristic is the called the estimator, and the value of the parameter that we want to estimate is called estimate. You don't need to worry to these two definitions. We will see them in next chapters as well again. So yes, so there are a few concepts, more concepts. Sample population, you have to decide which population you are targeting. For example, if you are talking about growth of apples in Pakistan, growth of orange apples and like trees like this, then if you start sampling from Thar area or Cholistan area, that means you are not in the correct place. So you have to see what you want to do and what is your frame of reference, frame of data collection. So this is even further details that if you are collecting data for about like telephone numbers, then you have to use telephone book. If you are using locations in the city, estimating the locations which are good, so this is city business city maps or city business book directories. Or you want to see how many businesses in the city, and you want to do like FBR do random sampling, and they select people who are like maybe or may not be doing some forgery. Forgery means they are not paying their tax properly. So they do random sampling out of the total taxpayers. Suppose there are 2 million tax or 3 million taxpayers, they will randomly select 1,000 people every month, and from 1,000 people they will try to estimate whether there is forgery, yes, or what is the proportion of forgery cases in businesses. So this is also a frame. Frame means the target population that you want to work with. Parameter, statistic, and we will see the sampling distribution in next slides. So this is the one I made properly. So you see sample mean X bar or mu cap. Whenever we use cap sign, that means we are estimating, this is the estimated value. For example, this mu cap means this is the estimated value for the actual mu. Actual mu is a population mean. Sample variance S square, and the estimated based on this sample is called sigma cap square. So remember, whenever we use caret sign or cap sign, that means it is estimated from sample observations. Okay, similarly, sample proportion is small p or capital P cap, sample ratio, then small r or r cap, etc. So one more thing is the sample correlation. Correlation is represented also by r, but or rho. You know, r rho is a Latin word. So to estimate or to make conclusion about population parameter. For example, we want to estimate population parameter mu. Mu is the mean. And population variance sigma square or population proportion. So these are all different type of population characteristics. Population characteristics called parameter. Sample characteristics are called statistic. So this is a visualization that why we do this. But why we are doing sampling? Because whenever we want to make decisions about the population, we have to select a sample. For example, parts production, for example, towel company, then you cannot test every towel in your population. For example, you have 10,000 towels produced by a machine. You cannot test all the 10,000. You have to select a sample of 10, 20, or 50 towels, and from those sample, you have to decide whether the whole production of 10,000 towels is acceptable or below the quality or not acceptable quality. So that means in real life, it's very common practice if you go to industry or anywhere that we do working with the sample to make decisions about the whole population. It's very common. But why it is so useful? Because you can save your cost. For example, if you have 100, 10, 1 million people in some population, in something, in somewhere, and from those 1 million population, you just sampled 10,000 people, that is equal to 1% of the total. So what happens when you do only 1% of this 1 million people? Even then, your results would be very close to the population results. You know that you don't know the population results, but you can use this theoretical concepts to say if you have a large sample like 10,000 out of even 1 million, your results will be like 95% or 90% accurate. So see, for example, if I say 1 rupee per person data collection cost and data processing cost, that means here you are using 10,000 or maybe 15, 20,000 rupees. But if you want to do whole population, that is 1 million, it will cost at least 1 million rupees to analyze the whole population data. Very expensive plus time consuming. So this was the example that I gave you. We have 5% cases on 40,000, and based on this, we say that the whole population, whole Pakistan, have a value of 5%. So this is also one other example. Okay. One thing that we have to use here is the combination and permutation formula that I will show in the next or few next slides, after 2-3 slides. There are different types of sampling. One is called simple random sampling. Simple random sampling stands for that suppose you have 100 people and you have to select 5 people from those 100 people. One approach could be that you draw random numbers from 1 to 100 in Excel, and from that you can select any 5 randomly. That is called simple random sample or sampling random sampling method. This is the most easy method for the data collection, because you just have to use random numbers to select people. If there are 100,000 people, you will generate number using Excel or any software, the numbers between 1 to 100,000, and select only, say, suppose a small n. A small n means sample size, a small n number of people from there. So that means it's the most easy and it's most common in our daily life. Systematic sample, like every case, for example, you issued token number like primary key to each individual, and that primary key is the token number of each person. From there, then you selected, suppose you selected every 7th person of the whole population of the whole primary key database, every 7th person, and suppose 7, 14, 21st, 28th, 35th, 42nd, 49th, and you selected so many people from there. So sometimes in Hajj, I don't know, Hajj quota system or Hajj system, they sometimes use this case selection technique, that every 5th person will go for Hajj, or every 19th or every 20th person will go for Hajj, depend on how many applicants are there. Stratified sampling is the second most important approach. It is called stratification. Stratification stands for when you have different type of people or different type of objects in your population. Like in Pakistan, there are people having salary less than 10,000, less than 20,000. Suppose 18,000 is the lowest. Suppose people having salary less than 18,000. Then there are some people, a class which have salary up to 50,000. Then there is class of people having salary up to 150,000. So you can see that the life standard depends on income of a family. So that means you can say if the income is high, the life standard is high, or otherwise you can say you can stratify the population. You can segment the population into different zones, into different classes, like a lower class, middle class, higher class, and like top class, something like this. You can have 3 to 5 different number of classes, and then from each class or each segment of the population, then you select the sample observations. This is called a stratified sample. And you see in this city of lights, maybe lights. So in this city, you know that there are variety of people, variety of areas having low income and having very high income. So that's the way that stratified sampling is used in real life. In some religions, they have human segmentation as well, like those people who are very low in their in the category in the society, and there are people who are very high, categorized as very high in the society. So they used that approach for some other purposes. So in short, stratified sampling is the second most important approach. The other approach are cluster approach. We will not go into detail, and multi-stage sampling. The main thing that we use in real life most of the time are stratified sampling, and simple random sampling, SRS. This is called SRS as well, simple random sampling. And we will focus only on this one in this module because the theoretical concepts are dependent on this one only.
Sir,
So, Yes, Aniya. Okay, so there are like many different applications of this simple random sampling and stratified sampling in statistics, data science, and machine learning that I have used in my life, in my practices. So now further definition, capital N, suppose capital N represents the population size. For example, population of a city may be 1 million, population of a country may be 220 million, and small n represents the sample size, the small portion of the population. Simple random sampling is the approach which is the most easy approach, which is like every individual has an equal chance of being selected. So if there are 100 people in a population, then every individual has the probability of 1 divided by 100. That means 0.01 chances of being selected in a sample. So this is a way that is called simple random sampling, easiest, most easy. So now if we are doing simple random sampling, there are two things that we have to consider. One thing is called either we are repeating those individuals who were selected in the first sample. For example, person number 1, 2, 3, 4, 5 are selected in sample 1. And in suppose another sample 1, 3, 5, 7, 9 are selected. That means there are few people who were in first sample, they are repeated in the second sample. In combination permutation, we call it with replacement or with repetition. With replacement or with repetition means one or more than one element of your sample or your selected values is repeated from previous values or previous samples. So then in that case we say the number of samples is small m. Capital N is the population size, power small n is the sample size. So this means if you have a population of 100 individuals, say 100 students, and you want to select a team of 5 students, it will produce 10 power 5, sorry, 100 power 5, 1,000, 10,000, 1 million. Yeah, it will produce 1 million number of samples. If you have a class of 100 students and you are selecting 5 students for some competition or something. So this means if you use this sampling without replacement, with replacement, there would be a lot of many number of samples, even when you have only 100 people in population. That's why in the next slides, I have considered a population of very small size, 5 or 6 individuals, to give you an example. Because you are from computing or computer science, so you know programming, and then you can use programming to simulate even 1 million or 10 million or whatever the number of samples. And there are softwares which are available to do this for you. Most commonly, we do sampling without replacement. That means without replacement means if one individual or one sample has been selected, then you will not repeat it. In the with replacement, you say that suppose 1, 2 is different from 2, 1, and 1, 2, 3 is different from 2, 1, 3 or 3, 2, 1 or 1, 3, 2, something like this. So in with replacement, we have to consider all possible pairs without order important. In here, combination and combination small n, we do not consider the order. Like that means 1, 2, 3 equals to 3, 2, 1 equals to 3, 1, 2, and so on. So this is the difference. It's okay. Yes. So this is the definition of a point estimator. For example, if you want to estimate population parameter mu, you use the sample point x bar. If you want to estimate population standard deviation sigma, you use the single point small s. Small s means sample standard deviation. Similarly for proportion, and if you want to estimate the population of individuals, then you use sample information. So you see the difference between sample result, statistic, and population parameter, that is called sampling error. If there is a large difference between sample result and population result, that means your sample is not good. And if the result is close to 0 in absolute, that means your results are good. Your sample values which you have collected, they are good representation and they can serve as a good representation for the population. But one question arises here. Because in real life, we don't know the mu. Mu means a population parameter. How I can say that there is a small sample error or sampling error or a large sampling error? So if you don't know mu, But even then, if you want to calculate x bar minus mu, then you have to use some other approaches that are called bootstrapping, that are called M estimation and other things. We will not cover those things in statistics course. They are part of like the machine learning and data mining type of modules. So there are other approaches which is called sampling, resampling. You repeatedly sample from your population to understand that what happens in the whole, what is happening in the whole population. So, but we are not very much focused on this as a first year student. Now stop this. Yes, so I will continue on this on number 5.2.